prove that root 2 is an irrational number. So we will prove on the contradictional basis. Let us assume that root 2 is a rational number. So we take p by q, where p and q are integers and the denominator q is never equal to 0, and here p and q are co-prime as they are having only one common factor as 1 only. Co-prime means having the common factor 1. So now we are squaring this. Root 2 is equals to p by q. We get 2 is equals to p square by q square, cross multiplying. 2q square equals to p square. It means that 2 divides p square and also 2 will divide p. If 2 divides p means p is a multiple of any variable. So let us take that. Let p is equals to 2c. And now if we are going to replace the value of p here as in place of p square, we get 2q square equals to 2c the whole square, which is equal to 4c square. So 2 4 कट जाएगा तो 2, so q square equals to 2c square. So 2c square equals to q square. Again we can say that 2 divides q square and 2 also divides the q. It means that p and q have at least one common factor as 2. Here also it divides to 2, here also it divides 2. So it is having a one common factor as 2, but we have taken earlier that p and q are co-prime. It will have only a one factor as 1. So this is a contradiction. Our assumption therefore it is wrong. So therefore root 2 is an irrational number. So in the same way as I have discussed just now, root 2 is an irrational number. In the same way you can solve for root 3, root 5, root 7, root 11, and you can practice at home the same type of problem. Root 3, root 5, root 7, root 11, and rest of the variety of the problems related to irrational number I will discuss in the next class. Now for class 10th we are going to prove one question. Prove that 7 root 5, 2 plus root 3, 5 minus root 2 and root 5 plus root 3 are irrational numbers. So first let 7 root 5 be a rational number. So 7 root 5 is equals to p by q, where q is not equals to 0 and p, q are co-prime. That is, they are having a factor of only 1. Now 7 is equals to 7 root 5 is equals to, we are having p by q. So p root 5 will be equals to p upon 7q, equation 1. As in equation 1, p and q are rational, which implies that p upon 7q will also be a rational. Will also be a rational, but root 5 is irrational, which is a contradiction, as a rational number is never equals to an irrational number. Therefore 7 root 5 is an irrational number. Now it comes to the second question, that is 2 plus root 3. Let 2 plus root 3 be a rational number. So in the same way 2 plus root 3 is equals to p upon q, where q is not equals to 0 and p, q are co-prime. So what we have to do it, the radical quantity we will left out at one side and the non-radical quantities will transpose to the other side. That is, root 3 will become equals to p by q minus 2. Root 3 will be equals to p minus 2q upon q. Now, since p and q, since p and q are co-prime integers, therefore p minus 2q upon q is a rational, but root 3 is an irrational number, which is a contradiction. Therefore, our assumption is wrong. So, therefore, 2 plus root 3 is an irrational number. Next, we move to next question. Let 5 minus root 2 be an irrational number. In this case, 5 minus root 2 will be equals to p by q, where p and q are co-prime. So here also what we do, 5 minus p by q is equals to root 2. This p by q we transpose this side, left side, and root 2 radical quantity to the right side. Now after taking LCM, 5q minus p upon q is equals to root 2. Equation 1. Since p and q are co-prime integers, which implies that 5q minus p upon q is a rational, but root 2 is an irrational. Therefore, it is a contradiction. Therefore, our assumption is wrong, as a irrational quantity is never equal to a rational quantity. Therefore, we can say that 5 minus root 2 is an irrational number. Let us see once again. Let 5 minus root 2 be an irrational number. 5 minus root 2 equal to p by q. P and q are co-prime. When we transpose, we get 5 minus p by q equals to root 2 after taking LCM. 5q minus p upon q equals to root 2. Since p and q are co-prime integers, so therefore 5q minus p upon q, the LHS quantity of equation 1 will be a rational. But in the RHS, root 2 is an irrational quantity, and the irrational quantity is never equal to a rational quantity. Therefore, it is a contradiction. So therefore, our assumption is wrong, that it is a rational number. 5 minus root 2 be a rational number. So 5 minus root 2 is an irrational number. Now the last one, root 5 and root 3. Here both the quantities are radical. In the first one it is a multiplicative form. In the second one it is an additional form. In the third one it is a difference. And here both the quantities are now radical. So let root 5 plus root 3 be a rational number. So root 5 plus root 3 equals to p by q, where p and q are co-prime. Now what we have to do it, no need of transposing. We have to square this equation on squaring both the sides. When we square root 5 plus root 3 the whole square equals to p by q the whole square. Now it is of the form a plus b the whole square. Since we know that a plus b the whole square is equals to a square plus b square plus 2ab. So root 5 square plus root 3 square plus 2 root 5 into root 3 equals to p square by q square, which becomes 5 plus 3 plus 2ab, 2 root 15, which is equals to p square by q square. 5 plus 3, 8, 8 plus 2 root 15 is equals to p square by q square. 2 root 15 is equals to p square by q square. This non-radical quantity will transpose towards the right. So 2 root 15 after LCM here in the RHS, p square minus 8q square. So root 15 is equals to p square minus 8q square upon 2q square. This is our equation number 1. Now as in the equation number 1 we can see that since p and q are co-prime, so this quantity of the RHS of equation 1 will also be a rational, but root 15 as root 3 and root 5 are the irrational, so their product root 15 will also be an irrational number, and an irrational number cannot be equal to a rational. Since p and q are co-prime, therefore p square minus 8q square upon 2q square will be a rational, but root 15 is an irrational. Therefore, it is a contradiction. Therefore, our assumption is wrong that root 5 plus root 3 is a rational number. Therefore, root 5 plus root 3 is an irrational number. Once again, we can see root 5 plus root 3 equals to p by q. P and q are co-prime. On squaring, in case of both the quantities, if they are in the additional or subtraction form, they are radical. So what we have to do, we have to square both the sides. So a square plus b square plus 2ab, we get root 5 square 5, root 3 square 3, 2 root 5 into root 3, 2ab, 2 root 15, p square by q square, 5 plus 3, 8. When we transpose this non-radical quantity towards the right side, we get 2 root 15 equals to p square by q square minus 8 after LCM. P square minus 8q square upon q square. This non-radical quantity coefficient 2, we can bring it down. P square minus 8q square by 2q square. Now since p and q are the co-prime, so therefore this quantity RHS will be a rational. But a rational quantity cannot be never be equal to a irrational quantity root 15, so which is a contradiction. Therefore root 5 plus root 3 is an irrational number. So in the same type of problems, 7 root 5, you can take 3 root 5, you can take 5 minus root 3, you can take 3 plus root 2, you can take root 3 plus root 2, and you can prove it yourself. You can do practice of such various problems in the same way. Thank you.